This is 7th grade, lesson 15, module 4, on solving area problems using scale drawings. Now this is going to be mostly a peer activity because this is the last lesson of this particular topic. So by now we should have a little bit of an understanding, but I am going to go ahead and help out just a little bit here in class and as well as on this video tutorial. So it says for each diagram, drawing 2 is a scale drawing of drawing 1. Complete the accompanying charts for each drawing. Identify the side lengths, determine the area, and compute the scale factor. Convert each scale factor into a fraction and percent. Examine the results and write the conclusion relating to the scale factors of their area. All right, sounds like we have an awful lot to do, but it's really not that bad. So it's nice that we're dealing with squares because it makes solving the area a lot easier. So each of the side lengths of drawing 1 is 3 units, and for drawing 2 is 9 units. So when we go to find the area, remember area is length times width. So that's going to be 3 times 3, which gives us 9. And here we're going to have 9 times 9, which gives us 81. So far we've already done this portion, half of it. Now we need to find the percent of that. So we're going to go 9 equals the percent times 3. So I'm going to divide by 3. And 3 goes into 9. These cancel. 3 goes into 9 3 times. So what is the percent of that? We're going to take 3 and we're going to multiply it by 100. And we get 300%. All right, let's try the other one with the drawing 2. So this one we're going to say 81 equals the percent times 9. So we're going to divide both by 9. These cancel. 9 goes into 81 9 times. Times that by 100 to get the percent. So this one here is 900%. All right, I need to move this up to answer those bottom questions right quick. It wants to know what is the scale factor. Well, my scale factor is going to be 3 because I'm increasing it 3 times bigger. And what is my quotient area? That is my 9. All right, the 9 comes from the area. So what did you get for areas? We got 9 as our number. And what did we get for the scale factor? We got 3. Now, again, we turn those into percents. We turn that into 300 and 900%. But they just wanted to know the scale factor and just the quotient of areas. All right, let's try the next one. So we have some circles here. And we have a radius. We're going to count this out. We have 1, 2, 3, 4. We have a radius of 4 here. And 1, 2, 3, 4, 5, 6, 7, 8. A radius of here of 8. So drawing 1, radius of 4. Drawing 2, radius of 8. Let's find the percent. 8 equals the percent times 4. Okay, we're going to divide out that 4. Those cancel. 4 goes into 8 2 times. Multiply that by 100 to get the percent. And we have 200%. But before I walk away, this answer here of 2, that's my scale factor. That means we had this drawing, and this one is 2 times bigger. Okay, so basically what happened to the 4 for it to become an 8? We got 2 times bigger. That's my scale factor. Okay, now let's do the area. Area on a circle has its own special formula. It's A equals pi radius squared. So I'm going to say pi times my radius of 4, and I'm going to square that, which means 4 times 4. So I get 16 pi. And I'm just going to leave it in pi form. We're not going to multiply it by pi 3.14. We're just going to leave it like that for now. And let's do the next one. We have pi times 8 squared. So this gives me 64 pi. So now when I go to find the percent, I'm going to say 64 pi equals the percent times 16 pi. All right, we're going to divide this out. We're going to divide out the 16 pi. These cancel. What you do to one side, you do to the other. Now on this one, my pi's cancel right away. Those are gone because they're the same thing on top and bottom. So 16 goes into 64. You do that on your calculator. You should get 4. Now 4 is my quotient of areas. All right. but they want the percent as well. So this is one of my answers. And we're going to multiply that by 100, and I get 400%. So now let's find our scale factor and quotient down below here. So if you remember, our scale factor was 2, and the quotient of areas was 4. All right, let's go ahead and go on to the back. So we have these two drawings. Drawing 1 and drawing 2. Now they went ahead and actually told me, let me put this back up. They told me the length of drawing 1 is 12 units and the length of drawing 2 is 6 units. So real quick, we can find our scale factor. What happened to 12 for it to become a 6? We cut it in half. There's my scale factor right there. But I'm going to show it to you with some math down here. So we have a drawing 1 has side length of 12. Drawing 2 is 6. We're going to find the percent. So we're going to say 6 equals percent times 12. You always just go off the second image. This being the first, that being the second image. Okay. The second image is the equals. Now we're going to divide by 12. Those cancel. This comes down to half. Yeah. Isn't that what we wrote right there? There's my scale factor. And what is half as a percent? 50%. All right, I need to move this up real quick. Now we need to find the area. If you remember, area is your length times your width. So here I'm going to have 12 times 12, which gives me 144. Here I'm going to have 6 times 6, which gives me 36. And let's find that percent. So the second image equals percent times the first image. Divide out the 144. Those cancel. And reduce this fraction. Reduce down to 1/4. So 1/4 is the quotient of areas, but this as a percent is 25%. So again, my scale factor was half, and my quotient of areas was 1/4. Now there is a conclusion statement at the bottom here. They want to know, what can you conclude about this? Well, I can conclude that two scale factors multiplied together equals my quotient of areas. There you go. All right, let's do example 1. Example 1, find the percent of the area of the large square. What is the percent of the area of the large square is the area of the small square? All right, so first of all, I went from 1 unit. Well, actually, I went from 5 units to 1 unit. So I cut that and made it smaller, and I made it smaller by 1/5. Just putting the smaller over the larger. So that's my scale factor. Now, if I say 1/5 times 1/5, I get 1/25. Now, if I divide that to get a decimal answer, I get 0.04. So what is that percent? That is 4%. All right, let's look at example 2. So example 2, we have 2 circles here. One is shaded, one is not. All right, first thing we need to do is find the radius. So you find the middle point and draw a line straight out from the center. And you can see that that is 2 units long. All right, and then from here as well, from the larger circle, we're going to go out. I have 1, 2, 3, 4. All right, so right away, I can see that I went from a 4 to a 2. So what did I do with my scale factor? If I went from a 4 to a 2, I cut it down into half. I made it half. That's my scale factor. So let's find the area, or the quotient of areas, I should say. Let's find the shaded region. So we're going to say half times half equals 1/4. 1/4 as a percent is 25%. So this is 25% is the smaller circle. So if this represents 25%, this smaller circle, and the whole thing has to be 100%, then what is the small circle not taking up? What percentage is it not taking up? So we're going to say 100% minus the 25% for that small circle leaves me with 75% for the larger circle. And that's it. All right, this next one's the last one I'm going to do, and then the rest you are doing with your peers, or if you're watching this video at home, you're just going to try on your own, or you can ask a friend, of course. So here we go. Find the area of the shaded region in the larger figure. It is approximately 21.5 inches. All right. I got to move my colors out of the way here. There we go. Write an equation that relates to the areas using the scale factor and explain what each quantity represents. Determine the area of the shaded region of the smaller drawing. All right. So we have some side lengths here. And kind of like what we were doing before, we're going to set those proportional to each other. So we're going to say we have 6 to 10. We can reduce that down to 3 to 5. Now, if I divide this, I get 60%. Well, actually, you get 0.6, and then we move the decimal 2 places to the right. Again, we're going to take that scale factor, and we're going to times it by itself again, and this will give our quotient of area. And this gives me 9/25. Now, since they told me that the larger figure, its shaded region is approximately 21.5, I'm going to take 9/25 and I'm going to multiply it by 21.5. All right, so I'm going to grab my calculator for this one. I want to see if 25 can go into 21.5. So let's see. I have 21.5 divided by 25. I get 0.86. Well, sort of. All right, let's try another way. Let's say 9 divided by 25. Do I get a decimal there? All right, let's try this one. So if I turn this into a decimal, I get 0.36 times 21.5. That might be a little bit more visually appealing. So let's see, 0.36 times 21.5, and there we go. And I get 7.74 square inches. And that's it. You're done. All right, so you and a peer will do the next page and a half, and that will be graded. This is the end of this topic, so you will soon be moving on to the next topic. And this concludes our video.